If you want to make a tower defense game, this is how to make enemies follow a series of waypoints along a path and how to optimize that code for better performance. Click the like if you want me to do deep dives into more game genres like this. I create a new blank project with universal 2D render pipeline. I'm using Unity 6, but you can use any Unity version you want, it doesn't matter. In Assets Scenes, I rename my scene to Game. Inside the Assets folder, I create a new folder I call Art. You can download all art assets in the Resources section below. I'll start with this simple spreadsheet, where I have one frame representing an enemy and another frame representing a point along a path. With the image asset selected, inside the Inspector tab, if you're using pixel art like this image, you want to make sure it's not blurry. So we set filter mode to point no filter and compression to none. I click Apply, I open the sprite editor and slice, grid by cell size. These frames are 100 × 100 pixels. I click Slice, then Apply. Now I can use this little arrow to expand the sprite sheet and see individual frames. Here in the hierarchy window, I see all the game objects that make up my game scene. I can right-click and create an empty game object. I call it Path. Every game object in Unity has a transform component, which defines the object's position, rotation, and scale. We can use these tools here. For example, I can select the Move tool to move the object around the scene. And when I do that, its position values change. I can also right-click and reset transform to center the object in the middle at coordinates 0, 0. So this is the game scene. This white rectangle represents the visible game area. If I open the Game tab, this is what the game will actually look like when played. In my Art folder, I can expand my sprite sheet. If I drag and drop this frame into the scene, Unity will automatically create a game object for it. Unity will also automatically detect that this game object has an image. So on top of its transform component, it will also give it a sprite renderer component, where we can do many things to handle and adjust the image. I will rename the game object to Waypoint. With the Waypoint game object selected, I can use the Move tool to move it around the scene. Doing that will update its X and Y position. I can also set the object's position manually by changing these values here. On the Game tab, this is what our game looks like so far. I'll change the aspect ratio to Full HD for better rendering, and I'll zoom out using this scale slider. I like to keep my small game preview down here. Now, when I make changes to the scene, I can instantly see how those changes affect the playable version of my game. Now that we understand the basic Unity layout, let's build something more interesting. Inside my Assets folder, I create a new folder I call Prefabs. I can drag and drop my Waypoint game object into this Prefabs folder, turning it into a reusable game asset. Prefabs are pre-configured, prefabricated game objects. Let's say I have a game object like this Waypoint, and I configured it in a specific way. Now I want multiple of these game objects, all configured the same way. Instead of repeating the process over and over, configuring them one by one, I turn it into a prefab and I can duplicate it as many times as I want. Notice that after turning it into a prefab, it changed color. I can delete it from the scene now, and I can just drag in as many as I need. If I want to make change to all of these copies, I can just change the main prefab in Assets and it will update all of them. I delete these and I leave just one for now. Game objects in Unity have components that give them special functionalities. Unity has many components we can add, and we can also create completely custom script components to write custom logic. So let's say I want to write a simple script that connects all of our waypoints with a line, and I want enemies to move and follow along that path. Inside Assets, I create a scripts folder. In Unity, we use the C# programming language. Let me show you how much you can achieve with just a few simple lines of code. Inside the scripts folder, I right-click, create, and I choose a MonoBehaviour script. I call it Path. Be careful here, you can't just rename this file later, because Unity will use that name to define the class inside the file. So make sure the name of your file and the auto-generated class name inside it match. I select the path game object, and I attach the path script as a custom component, like this. I double-click the script file, and Unity opens it in my default code editor. If you've never heard of MonoBehaviour before, all you need to know is that it's a special Unity class that allows us to take scripts and attach them to GameObjects as components, just like we did, and make the code inside that script interact with that GameObject and with others in the scene. MonoBehaviour is a fundamental building block of Unity. You'll see it all the time. MonoBehaviour also gives us access to so-called lifecycle methods, useful code blocks where we can put our code depending on when we want that code to run. You can also see that Unity created two most important methods. Inside the start method, we can put code we want to run only once at the beginning, and the update method is where we put code we want to run over and over. There are many more built-in lifecycle methods, and we will use some later on. For now, to keep this clean, I will delete them and I will just declare a variable. We are inside a custom path class we created. I want a variable that will hold an array of waypoints so that we can connect them together and send enemies along that path. In C# we define variable this way. We start with an access modifier. If the variable is public, then everyone can see it. Or if it's private, it's accessible only from this script. I need my waypoints to be available from other scripts, so I set the access modifier to public. The second word defines the type of value this variable will store. In this case, it will hold an array of prefabs. Each waypoint is a prefab, and prefab is a game object. Square brackets mean it will be an array of game objects. And the last part is whatever I want the variable to be called. So, who can access this variable, what data type it holds, and what name we give it. In C# we define all variables like this. If I save changes and go back to Unity, on the path game object, inside its custom script component here, I see that waypoints variable. It's an array, so I can click plus to add elements to it. Because of the variable type we defined, you can see these fields expect a value that is of GameObject type. I go to the prefabs folder, and here we have a waypoint prefab, a pre-configured, prefabricated GameObject. I will need 5 of them in total, so I drag them one by one into the scene until I have 5 copies. I select the path GameObject again, and I will drag this first waypoint into the first field in the array, like this. Waypoint 1 GameObject into this field, and I do the rest. Ideally in the same order, so we have an increasing sequence of numbers that matches the order in the array. This icon is to show and hide gizmos. In Unity, gizmos are visuals that appear in the scene view, but not in the game view. We will use gizmo lines to visualize our path connecting the waypoints, and then we will make enemies move along that path. So let's make sure we have gizmos enabled, and let's open our path script. Unity has a built-in method called onDrawGizmos that we can use to draw visuals in the scene view to help us design or debug our game. If this waypoint array has some elements in it, if the length is more than 0, I create a for loop that will cycle over all the elements in the array. We set the color to gray, and for each of these waypoints inside the waypoints array, we will draw a line connecting them. Unity has a built-in gizmos drawLine method that takes the start point and end point, and it will draw a line between these two positions. So I want to start the line at the position of the game object at this index. I access its transform position, and I want to end the line at the position of the next waypoint, so index +1. As we cycle over the array, this index value is increasing by 1, and we are drawing lines between the waypoints. When we reach the last index in the array, there will be no index +1 anymore, so that would give us an error. So I only want to draw these lines until we reach the second to last element. Only draw the lines between this and the next index if the index is the length of the waypoints array -1. Let's save that. You can see a line connecting all our waypoints. Now I can select individual waypoints, and I can use the Move tool to modify my path in any way I want. Maybe I will have some tile map behind, and I will make sure this path matches a road in the artwork that I want the enemies to follow. Notice that because the line is drawn using gizmos, it's visible only in the scene view, but it doesn't render in the game view, which is exactly what we want. I left-click the first waypoint, and I shift-click the last one, selecting all the game objects in between. I will parent all of them under the path game object to keep the hierarchy organized. I can also rename this to path 1, because we can create multiple different ones in our game later if we want to. With path 1 selected, I use the move tool, and I can also move the entire path now, like this. I can select individual waypoints to modify them in any way I need. This technique is extremely useful for tower defense games, racing games, as well as something like MOBAs, such as League of Legends, where you have NPC minions moving automatically along the lanes. You can use the same exact technique we have here for a 3D game as well. Maybe I also want to give the waypoints some labels, so I can easily see at a glance which waypoint corresponds to which game object. Inside onDraw gizmos, I can do that here. If we want to define styles for our text in Unity, we can use the built-in GUI style class. GUI stands for Graphical User Interface, and we can use this class to define visual styles, fonts, colors, alignment, and so on. Now I can take that style and I set its normal text color to white. And most importantly, I set alignment to middle center because I want the text to be horizontally centered around each waypoint. I can draw text using handles built in Unity class. We need to include the Unity editor namespace up here to be able to use handles. Handles.label will let us draw a label in the scene view. We pass it 3 parameters. Where we want this label to be drawn, I want it at the position of the waypoint it belongs to, plus 0.7 units above it. The second parameter is what we want the label to say. I will make it display the name of the game object. We can see the names in this field here. And finally, as the third parameter, I apply our custom style we just created. If I save that, you can see we have little labels above each waypoint. In the game view, none of this will be visible. Perfect. Now, let's bring in some enemies and make them walk along this path. Inside Assets Art, I have my sprite sheet, and one of the frames is this simple enemy silhouette. I drag and drop this frame into the scene, and I rename it to Enemy. We can replace it with animated characters later, but first, let's focus on the pathfinding logic. I go to Assets Scripts and create a new folder I call Enemy. Inside, I create a new MonoBehaviour script. I will also call it Enemy. With the Enemy game object selected here, I drag and drop the Enemy script here as a custom component. I open the script, I delete all this code, and I will define a variable here. I start with serialize field in square brackets like this, and private. The type will be float, which is a decimal number, a number with a fraction part. I will call my variable move speed. I will also give it a default value, for example 3f, f for float. We know we have public variables which are accessible from other scripts, and they are also displayed here in the Unity inspector. Private variables are accessible only from the script, and they don't show up here in the inspector. If I want a private variable, but I want it to display in the inspector, I give it the serialize field attribute, like this. So if I save my changes and I go back to Unity, I can see move speed here, like this, and we see the default value of 3 I gave it. I want another private variable. This time I don't need to see it here in the inspector, so I don't use serialize field. The type is vector3, and I call it target position. Vector3 is a data type that has 3 components. We use it for position, for example, because position needs x, y, and z values. In terms of naming conventions, look at the custom names I'm giving these variables. We will follow .NET style naming conventions here. Public variable names are spelled in Pascal case, where the first letter is capitalized. Private variables will be camel case with an underscore prefix, And my personal choice is that serialized field variable names will be spelled like this, so that Unity can turn them into names that are nice to read in the inspector. These are just conventions. If you don't follow these rules, it will not break your code. But people use them because you can see at a glance what is a public and private variable. Inside the update method, which runs over and over, we want the enemy to move towards the target position. We learned about start and update lifecycle methods. There are many more. For example, we have the onEnable method, which runs every time a GameObject is activated. Inside, we'll put all the code that I want to run when I reuse this object, because later on, we will learn how to optimize our code for better performance by turning enemies into reusable objects. And every time we reuse the object, every time we activate it, code inside onEnable method will run. When the enemy gets activated, we will give it some target position. For example, just as a test, let's give it a new vector 3 and set the position to 4, 0, 0. X, Y, Z. As the update method runs over and over, I want the enemy to move towards that target position. So I set the enemy's transform position to a built-in MoveTowards method. This method expects 3 parameters: current position, target position, and move speed. So I pass it the enemy's current position, where it is right now, and its target position, where I want the enemy to move, and how fast it will move there, which will depend on the move speed property from line 5. I multiply it by time.deltaTime. DeltaTime gives us the time in seconds that passed between each call of update. If I account for the actual time passing by like this, we make sure that the enemy moves at a consistent speed on all devices. It's important because the update method might run faster on a more powerful device, but we don't want the device's ability to serve more frames per second to affect how fast things are happening in our game. Accounting for delta time is a very important technique that ensures the speed at which game events happen depends on actual time and not on the frame rate. This is one of the fundamentals of game development and something we have to always make sure we do. Okay, so we have the enemy, a target position of 4, 0, 0. Let's save that and play to see if it worked. We can enter play mode by pressing this play button up here. As you can see, the enemy is moving from wherever it is to the target position of 4, 0, 0 at the speed of 3 units per second. This is position 0, and these little squares are units. The horizontal x position of +4 is 4 units to the right from the middle. 1, 2, 3, 4. I exit play mode. We know our code works. So now, instead of making the enemy move to a position like that, I want the enemy to move from waypoint to waypoint following a path. I select my path1 game object and I open the path script. To move along the path from waypoint to waypoint, we need a method that will give us the position of a waypoint, depending on an index in the waypoints array. When I call it and I ask what is the position of the element at index 1 in the waypoints array, I want this method to give me x, y, and z position of wherever in the scene we placed this waypoint object. Indexes start from 0, so 0, 1, 2, 3, 4. So this method will expect a parameter of integer type, a number without decimals. I call it index, and it will return the waypoint array at that index we passed to it. It will give us the transform position of that waypoint at that index. So whenever I need to know where to move next, I will call this public getPosition method. To access that getPosition method we just defined from the enemy script, I need a reference to the path1 game object and to its path script component, which contains that method. So serialize field, private, type is path, because I want this variable to hold a reference to this custom path component. And I will call it, for example, current path. Now it's time to learn about another lifecycle method called awake. This method runs once when the script instance is first loaded, same as start, but it runs before onEnable and before start. Inside awake, I take current path and I need to point it from the enemy game object to this path1 game object. And on it, I need to find this path component. There are multiple ways to do that. For example, I call the built-in find method, and I pass it the name of the game object I'm looking for. I need to make sure the spelling matches the name of the object I'm looking for exactly. From it, I call getComponent because I'm looking for this path component here. So now, the current path variable holds a reference to this component. We need it because that component has this public getPosition method that we will want to call from the enemy script. Inside onEnable, I set target position to current path, this component, .getPosition, and I pass it index. And depending on the index value I pass it, it will give me the position of one of these waypoints, 0, 1, 2, 3, 4. For example, if I pass it index 3, it would give me the position of this waypoint GameObject. The reason I had to use awake here is the order of execution. onEnable runs before start, so I couldn't put this line inside start. I had to put it inside awake, because awake runs before onEnable, and I needed this reference to be ready at the point when enable runs. Don't worry about this too much, it will become easy to keep track of the more you work in Unity. You can always have a copy of this chart somewhere and check it when you need it. So if I set this to index 3, I go back to Unity, and I expect enemy will walk from wherever it is right now to the position of this waypoint. I enter play mode and yes, that worked, perfect. Let's try to set index to 0. Save. I expect the enemy to walk to this waypoint. Play mode. Great. We have most of the logic. All I need to do now is to make sure the enemy increases target index by 1 every time it reaches its target position, and that will make it move along the path we defined here. So let's define a private integer I call current waypoint. It will be 0, or 1, or 2, 3, or 4, as the enemy moves along the path and changes targets. Every time we activate or reactivate this enemy, set its target position to be the first waypoint on the path, index 0. As the game runs, we check when the target position was reached and we set a new target position. We need to know the relative distance, how far is the enemy from the target position, the difference between the enemy's current position and its target position. The enemy can be to the right or to the left, so the value can be negative or positive, but we want to disregard that plus or minus. We only want the distance between these two positions. We don't care about the direction. That's why I want the magnitude of the vector. If the enemy is close enough to the waypoint, to its target position, let's say if the distance is less than 0.1 units, we increase the current waypoint value by 1. And we set the enemy's target position to the next waypoint in the path, like this. The enemy will move towards that next target position, and again, when it's close enough to it, it will increase the index again to move towards the next waypoint. I save and play to see if it works. The enemy is moving towards one waypoint after another, following the path we defined. When it reaches the last waypoint, we get an error, so let's fix that. Only increase the current waypoint by 1 if we are at an index at least 1 less than the length of the array. Else, we know the enemy reached the end of the path, so we will deactivate the enemy. We set active to false, like this. I save and play. The enemy follows the path, and when it reaches the end, it gets destroyed, it gets grayed out and deactivated. I create an empty game object and I call it spawner. I want to create a game object that will spawn enemies at a specific interval. In the game later, it can be a cave that orcs are coming from, or something like that. I reset transform just to make these numbers nicer. No real reason for this otherwise. Inside the assets scripts folder, I create a new MonoBehaviour script I call spawner. Spawner game object selected here, and I attach spawner script as a custom component. I delete all this code, and I define a private float spawn timer and spawn interval. I set it to 1 second by default. Spawn timer will count from 1 second down to 0. It will spawn an enemy and it will count again. So as the update method runs over and over, we are reducing the value of spawn timer by delta time, by real time that is passing by between updates. When spawn timer is less than or equal to 0, we set spawn timer back to spawn interval, which is 1 second right now, and we spawn an enemy. This method doesn't exist yet, so let's write it. Private void spawn enemy. Inside, I create a temporary helper variable. Type will be GameObject, and I call it spawned object. To create a copy of a GameObject from a prefab with code, we call the built-in instantiate method. And we pass it the prefab we want to create a copy of. This prefab variable doesn't exist yet, so let's define it. Public GameObject type, I call prefab, like this. Pascal case, because this is a public variable, so I have to change the spelling here as well. Notice I'm keeping everything generic so that I can set this prefab to be enemy or any other prefab object we will have in the game later, so we can use this spawner class to spawn pretty much anything. It can be very useful. Once we create spawned object from a prefab, we take it and we set its transform position to be the same as transform position of the game object this script is attached to. So the position of spawner game object. Wherever I place this spawner in the scene, that's where game objects will be spawning from. So now I have this prefab field, and whatever prefab I put there, that's what this spawner will start producing copies of. Save that, and in Unity, I see that prefab field here. I go to Assets, Prefabs, and I drag and drop enemy game object in here, turning it into a prefab. I can reset its transform to keep this cleaner. I delete the enemy game object from the scene. Spawner selected, and I drag the enemy prefab into this prefab field. I enter play mode. And enemies start spawning. They start from wherever I placed my spawner game object. They move towards the first waypoint in the path, and they follow the path. When they reach the end of the path, they get deactivated and grayed out here in the hierarchy. As you can see, we keep creating new enemies and deactivating the old enemies. I can also destroy the old enemy game objects completely, but for performance reasons, we want to reuse them instead. So instead of constantly creating and destroying enemy game objects, we want to create a pool of, let's say, 10 enemy game objects. We activate them when we need them, and we deactivate them, returning them back to the object pool instead of destroying them. Object pooling improves performance by reusing inactive objects instead of repeatedly creating and destroying them, which reduces memory allocation and garbage collection overhead. Let me show you a quick and simple object pool logic I like to use for my games. Inside Assets Scripts, I create a new MonoBehaviour script I call Object Pooler. Let's open it. Inside, I delete all this code. I define a private variable I call prefab, what kind of game object we want to store in this pool. For example, this would be the enemy prefab. We will also need pool size, how many of these prefabs we want to pre-instantiate. We want to fill this pool with inactive game objects and activate them when we need them. I will give it a default value of 5, but we can change that later. I will also need a data structure to hold them, private list of game objects. I call, for example, pool. To be able to use list, we need system collections generic namespace up here. Inside the start method, I will create the pool. I assign the pool to a new empty list of game objects first. Then I write a for loop that will cycle over the pool, 5 times in this case. And it will create new game object 5 times. Let's define that method here. Private method that will return a game object. I call it create new object. Helper variable of game object type we call obj. And we already know that to create a game object, we just call the built-in instantiate method, and we pass it the prefab we want to create a copy of. After we create it, we set active to false. We are just preparing some inactive objects into the pool here. We take pool from line 8, we add this new inactive object inside, and we make this method return that object. Let's save that. In Unity, I create a new empty game object I call enemy pool. I reset its transform. Again, our object pooler class is generic, so we can reuse this script to create different object pools in our game. Enemy pool selected, and I attach object pooler script as a component. Prefab field expects a game object that this pool will consist of. I go to Assets Prefabs, and I drag the enemy prefab into this field. The initial pool size is 5 by default, but I can change it if I want to. If I enter play mode, our script automatically creates 5 inactive enemy game objects, but they are all on the top level in hierarchy. I exit play mode. I would prefer if the pooled objects were parented under the enemy pool. In my script, I can pass instantiate an optional second argument that defines a parent. So I pass it transform, but it refers to the game object this script is attached to, in this case enemy pool. So I'm saying set enemy pool as the parent and nest these game objects under it. Inside spawner, I comment out spawn enemy for a while. Save that. Now if I play, start method runs and it creates 5 inactive enemy game objects and it puts them under enemy pool like this, keeping the hierarchy clean. The idea behind object pooling is that when I need a new enemy, I activate one of these, and when I destroy the enemy in-game, I just deactivate it, putting it back into this pool of available objects. Doing this is good for performance, mainly because of automatic garbage collection and memory allocation processes, which can cause our game to slow down if we are constantly creating and destroying new game objects. Object pooler will need one more thing, a method that will give us one of these inactive game objects when we need it. I will run a for each loop, which will iterate over all game objects in the object pool. We have that pool here on line 8, and as we just saw, it will hold 5 inactive enemy objects. For each loop, we'll check objects in the pool one by one, and when it finds the first inactive one, if active self is false, exclamation mark means false, it will return it, giving us the game object. We are creating 5 game objects initially. Maybe we are in a situation when all of them are being used, and this method will not find any inactive one. In that case, we just create one more, and we return it. If needed, we increase the size of the pool, like this. So now, whenever we need a new game object in the spawner, instead of creating a new one, we will call this public getPooledObject method. Inside spawner script, we will not be creating any new game objects here, so I can delete this line. When we spawn an enemy, we want to take the object pool and take one of those inactive game objects in there. I comment this out for a second. I create a variable. Type is object pooler, and I call it pool. What is the object pool this spawner will be spawning enemies from? Save that. In Unity, we see that pool field here. And I want to be spawning from this enemy pool, so I drag the game object in here. From it, I can call this getPooledObject method to get one of the enemies from the pool. So when I want to spawn a new enemy, I take the object pool, which we know will be enemy pool in this scene, and we call its public getPooledObject method, which will either give us one of the available game objects, and if there are none available, it will create a new one. Then we do what we did before. We position it wherever in the scene the spawner is, and we activate it. If you remember, when the enemy reaches the last waypoint, it will get deactivated, which will return it back to the pool of available objects. I will also uncomment spawn enemy here. Now if I save changes, spawner selected, move tool, and I will move it somewhere around here. I play, and enemies start coming from the spawner to the first waypoint, and then they will follow from waypoint to waypoint along the path. Notice that if I need more, object pooler script will create more, and at some point we have enough and we will start reusing the old enemy objects. Now we are reusing the same 11 enemy game objects over and over. If you want to know how to create a game world, give the enemies some animations, or how to turn this into a full game, I'll see you in the next video.